And then you'll realize that these will cancel out. And you're left with 1 plus root 3 over root 3 minus 1. And don't forget that negative sign that was out in front, always, from the very beginning. Remember this negative sign? So you still have that negative sign. Negative sign. And then you can multiply it in if you want to, or you can just leave it like this. But this is the final answer. This is it. Okay. We are now going to do another example. Here we go. Part 4, example 4. We're going to now kind of go the reverse order, in which case, instead of going from like cos x plus y or cos x minus y and expanding, we're kind of going from an expanded form and kind of going backwards. So here we have angle x, which is 7 pi over 12. Let's say let x be 7 pi over 12, and let y be 5 pi over 12. So this is the same thing as. Now you don't need to do this step. If you can just go straight into it, that's fine. If you know. So this is cos x, cos y plus sin x, sin y. Oops. Sin y. And if you go back to our compound angle formulas, which you need to memorize. I'll write this down. Let me see. The plus sign here. Did I get this right? No. Yeah, I got it right. This one. So this looks awfully like this. Cos x, cos y plus sin x, sin y. So that's the same thing as cos x minus y. So this is going to be cos bracket x minus y. And we know that x and y are 7 pi over 12 and 5 pi over 12. So that's very simple. That's just cos of 7 pi over 12 minus 5 pi over 12. We just do the subtraction. So that's just 2 pi over 12, which is obviously pi over 6. And we know pi over 6 is one of our special triangles, which I don't have here. Again, let me just copy that one more time. And you can just take a look at the special triangle and see that, hey, cos pi over 6, that's adjacent over hypotenuse, so that's equal to root 3 over 2, and that's the answer. So whenever a question is asking for exact values, you always have to use special triangles. Just remember that. Okay, I think we are almost done. Last example. We should be done. Oh, don't think it showed up. Let's try that again. There it is. All right. Part 5 application. Example 5. Evaluate sine A plus B where A and B are both angles in the second quadrant, given sine A is equal to that and sine B is equal to that. All right. This is confusing. The first thing is maybe draw a diagram to kind of, visualize this. We know angle A is in quadrant 2 because it says both angles are in second quadrant, so it's here. And this is, let's say, angle A, right? We know whatever this angle is, the opposite of that angle is 3, and the hypotenuse is 5. How? Because remember, sine of your angle is equal to opposite or adjacent, or if you remember, it's y over r. So r is being your hypotenuse, and your y value being your, the vertical y value. So we can figure out x now. We can figure out x. How? Using Pythagoras theorem. Whenever I have a right angle triangle and I know two sides, I can use Pythagoras theorem, a squared plus b squared equals c squared. And last time I did this with a student, what they did was 3 squared plus 5. I should write this down, sorry. What they did was 3 squared plus 5 squared is equal to c squared. And that's 9 plus 25 equals c squared, that's 34. And then you take the square root of 34, and then you get a value if you want to keep it in decimal, or you can keep it as radical, doesn't really matter. And this is completely wrong. When the student did this, I was like, absolutely wrong. It's the craziest thing you can do. Why? Isn't the formula a squared plus b squared? Yes, it is. But remember, c is your hypotenuse. So whenever you see two sides on a right triangle, you don't just always add them. Just remember, your hypotenuse is your c. So this is actually a squared plus 3 squared is equal to 5 squared. And then a squared is equal to 25 minus 9, which is 16. And a is equal to 4, because square root of 16 is 4. So my x value is 4. So just pay attention to that. I just want to mention, students making silly mistakes. As per usual. No, I'm joking. And then similarly, angle B, same thing, second quadrant. It's supposed to be a solid line. Terminal arm, usually. That's angle B. We don't really care what angle B is, because 5 over 13, that's what we're looking for. And same thing, 5 and 13, because opposite hypotenuse. We do the exact same thing, in which we use Pythagoras theorem. Solve for x value. That's going to be 169 minus 25. That's going to be 144. And then obviously that's 12. So my x value here is 12. Why did I do this? Because we are evaluating a plus b, right? We don't know what angle A is. We don't know what angle B is. But we do know that sine A plus B, if you use our compound angle formula, now there's actually more ways to do this than one. I just realized this, well, known it, but there's almost always in math more than one way of solving something. But yeah, since we're using compound angle formulas, we're going to use compound angle formulas. Sine x plus y is equal to sine x cos y, cos x sine y. So that is basically, in this case, that first sine A plus B is equal to sine A cos B plus cos A sine B. Now we know what sine A is equal to. We know sine A is equal to 3 over 5. So this sine A just becomes 3 over 5. Because we know that. It was given to us. We know sine B is 5 over 13. We know that. But what about cos B and cos A? Do we know those values? Well, it's not initially given to us, but now that we've drawn a triangle, we can solve for cos A and cos B, right? Cos A is going to be adjacent, which is 4 over 5. The only thing is you have to remember to use the cast rule to determine whether the ratio is positive or negative. Since this is in the second quadrant, your sine values are positive, which is fine, but your cos values are negative. So this is going to be negative 4 over 5 times 3 over 5 plus sine. And cos A, sorry, did I make a mistake? Yes, I did. So I wrote cos A where I should have written cos B. This is why you label your angles. So A is here. So 4 over 5 is going to be here. Negative 4 over 5. And cos B is equal to adjacent, which is 12 over 13. But negative 12 over 13. Remember that, right? And this is just basic multiplication now. That's just negative 36 over 65, I'm sure. And the 5 is actually just cancelled. So this is negative 4. Oh, wait, no, actually, I shouldn't do that. because we want the common denominator. Negative 20 over 65. And since they're common denominator, you just add them or subtract them. So negative 56 over 65. And that is the answer. That's it. That's how you do it. So this is an example of how to use compound angle formulas. And yeah, good luck. Bye, everyone.